July 14, 1999. Milwaukee stands in awe of Big Blue, a 567-foot crane taller than the Washington Monument, a 2,000-ton machine fueled by 11 roaring engines and 6 miles of steel cabling. 9 flawless lifts, each nearly impossible, had already crowned a new stadium roof, but with the 10th lift, management ordered the impossible. A 450-ton section hoisted against urgent warnings as wind speeds soared past safety limits. Seconds later, disaster. The collapse cost over $200 million and claimed 3 lives, all as inspectors watched, cameras rolling. Why, with all eyes on safety, did the world's most powerful crane fail in plain sight? The answer reveals more than a single flaw. It exposes a lethal chain of decisions no one believed would snap. The Lampson LTL-1500 transilift was more than a crane. It was an engineering spectacle. Rising 567 feet above the Milwaukee skyline, Big Blue outstretched even the Washington Monument. At over 2,000 tons, its mass equaled more than 500 pickup trucks. Its reach was legendary. A 460-foot main boom, plus a 200-foot jib, allowed it to position massive roof sections with surgical precision. To balance such immense forces, the machine carried 1,150 tons of counterweight. 11 diesel engines powered its every move, a mechanical chorus with the output of a small fleet of city buses. 6 miles of steel wire rope threaded through its structure, enough to stretch from Miller Park to downtown Milwaukee. Big Blue's lifting power was unrivaled. It could raise 1,500 tons in a single motion, roughly the weight of 10 adult blue whales. Even at a 230-foot radius, the crane could still hoist 500 tons, a feat that would challenge most machines even at half that distance. Its crawler tracks gave it rare mobility, letting it move across the site while carrying a load that would anchor lesser cranes in place. Every component was oversized, engineered for the heaviest, most demanding lifts. The operator's cab perched high above the ground, surrounded by a network of controls, sensors, and safety systems. For 9 consecutive lifts, Big Blue had performed flawlessly, delivering 400-ton roof sections onto the stadium's skeletal frame. Each lift pushed the boundaries of what was possible, but always within the machine's design limits. The scale was almost unimaginable. Steel, diesel, and wire rope working in perfect harmony, all to crown Milwaukee's new ballpark. Yet, for all its strength, even a giant like Big Blue was bound by the laws of physics. The limits were clear, and any breach would carry consequences on a scale as large as the machine itself. Winds swept across the half-built stadium, rattling steel and sending dust swirling around the base of Big Blue. By late afternoon, the National Weather Service recorded sustained winds above 26 miles per hour, with gusts climbing even higher, well past the crane's 20 miles per hour operational limit. In the cab, Terry Young watched the anemometer needle swing, the numbers refusing to drop. The roof section waiting overhead weighed 450 tons, nearly the size of a loaded Boeing 747. Every calculation said this was the edge of what the machine could handle, even in perfect weather. Over the radio, Young's voice cut through the static. He asked for a pause. The wind was too strong, he warned, and the new roof piece would catch the gusts like a sail. But on the ground, Masao Nishikawa, the site manager for Mitsubishi Heavy Industries America, faced a different pressure. The project's penalty clauses meant every hour of delay carried a heavy price. Schedules were slipping, and the stadium's opening day was already at risk. Soil beneath the crane had already sunk by a foot that morning, a silent warning that stability was not guaranteed. Yet, with the afternoon slipping away and the contract clock ticking, Nishikawa ordered the lift to proceed. The decision was final. The operator's hands stayed on the controls, but the authority to stop was gone. Wind readings on paper told one story. The reality, 400 feet above ground, was another. At that height, gusts can surge 40% higher than at the surface, turning a 26 miles per hour reading into a force capable of swinging hundreds of tons. As the signal came to start the pick, every hazard, wind, soil, pressure, aligned. The next few moments would test the limits of steel and the limits of human judgment. At 5:12 p.m., the moment the signal was given, a wall of wind swept through the open bowl of the stadium. The 450-ton roof section, already suspended high above the ground, caught the gusts like a canvas stretched across a frame. Instead of moving smoothly into place, the load began to sway, amplifying every pulse of wind into a force the crane was never meant to resist. At the base, the kingpin, an alloy steel shaft meant to anchor the entire rotating assembly, became the fulcrum for disaster. Wind pressure on the roof panel surged far beyond what ground-level readings suggested. Computational models later showed that gusts at boom height could spike over 40 miles per hour, nearly double the crane's rated limit. The roof section's broad face acted as a sail, multiplying the lateral load and twisting the structure against its own foundation. Inside the cab, Terry Young would have felt the machine shudder, the controls suddenly sluggish, the world outside tilting out of balance. A sharp metallic crack split the air, a sound captured on OSHA's running video. That was the kingpin, already weakened by an undetected crack and field modifications, giving way under the combined assault of shifting mass and side wind. In a fraction of a second, the bronze spacer beneath the kingpin shattered, ejecting fragments and shearing the locking ring clear. Freed from its anchor, the entire rotating assembly lurched sideways. The boom and jib, still bearing the full weight of the roof, began a slow, inevitable collapse. Steel cables snapped in sequence, counterweights tore free, and the lattice boom folded as if it were made of wire. The entire superstructure toppled in a chain reaction, the mass of 2,000 tons crashing down onto the site below. The collapse was over in less than 10 seconds, but the mechanical violence unleashed in those moments would echo through every corner of the construction industry. 3 ironworkers lost their lives beneath the tangled wreckage: Jeffrey Wisher, William DeGrave, and Jerome Starr. Each was working from a personnel platform, suspended high above the ground, when the falling boom struck without warning. Their names are etched into the memory of Milwaukee's labor community, and in 2001, a bronze sculpture by Omri Amrani was installed at Miller Park to honor their sacrifice. For their families, the aftermath was measured not in numbers, but in absence. The financial toll was staggering. Stadium repairs alone reached $100 million. Legal battles stretched on for years, culminating in a state record jury verdict: $99.25 million, with $94 million assigned as punitive damages. After appeals, the final settlement paid to the victims' families was $30 million. OSHA fines added over $500,000, and the year-long delay in opening the ballpark cost another $50 million. The project's final budget soared to $413.9 million, nearly $92 million above the original estimate. Tallying fines, lawsuits, and lost time, the total impact exceeded $200 million, making it one of the most expensive construction accidents in American history. Accountability reached beyond the courtroom. OSHA investigators, already present on site, captured the disaster on video and drove sweeping regulatory changes. Today, every major crane lift in the United States requires a boom-mounted anemometer to measure wind speed directly at elevation, not just at ground level. Computerized load monitoring systems became standard, and protective mats now sit beneath cranes on soft soil. Wind load calculations, once an afterthought, are now mandatory before any critical lift. These protocols are enforced by law, not left to judgment. The lessons written in steel and loss at Miller Park reshaped the rules for an entire industry. On July 14, 1999, winds of 26 miles per hour, well above the crane's 20 miles per hour limit, were officially recorded as Big Blue attempted its 10th roof lift. The operator's warning was overruled by site management, and within seconds the 2,000-ton crane collapsed, killing 3 workers and causing over $200 million in damages. Investigators confirmed the wind loads exceeded safe operating parameters, but why management dismissed clear safety concerns remains unanswered in public records. The disaster led to new industry rules: mandatory wind speed monitors, computerized load tracking, and stricter lift protocols. Today, these measures are standard on large construction sites. Yet, the official OSHA video and court documents still raise the question: could a single pause for safety have changed everything? What is certain is that Big Blue's collapse reshaped crane safety nationwide, leaving a lasting mark on both engineering practice and the families forever affected.